Okay.
So
So you get 4 side theta equals cos theta. Okay.
any idea?
And then you divide by 4 on both sides.
You don't need to. There's something you need to do though. What you do when you have a mixture of sine and cos?
You divide by like sine by cos, you get tan.
Well, don't divide both sides by cos.
So you get 4 tan theta equals, well, just theta.
4
Or
tan.
1.
Yeah, 1.
And then you divide both sides by 4 and do inverse tan of a quarter.
Yeah, what do you get?
14.04 to 2 decimal places.
14.0 degrees.
Okay.
Alright, how can we get an additional answer?
Do we make the quarter negative?
So for second answer for tan theta is equal to tan 180 plus theta.
Yeah.
So how can we use that to get an additional answer for theta?
So we know theta's 14, so we add 14.
Yep.
So you get 194.
Yeah, 194. And I think any more and it will be outside of the range.
Yeah.
Let's see. Alright, it could take... Nah, I'll leave it. Right, so a mixture of sine and cos, divide by cos. Other than that, you're just doing it normally. Okay, they're getting tricky. How about this? Well, they're getting very tricky. Hang on, is that really? Let's see. Yeah. Alright, how do we do this
one? Okay. So we just divide by cos 2 theta on both sides.
Yep.
And you get 2 sine. Well, no, you get 2 tan. Would it be theta? Would that just be 1?
2 tan, 2 theta.
Okay. Equals would. And then you divide by 2 on both sides.
Yeah.
Which gives you a half on the right.
And then how do you do part B?
Okay. So for that, would you do inverse tan on both sides?
Yep.
Okay. Which gives you 26.6 degrees to 1 decimal place.
Okay.
And then you divide by 2 to get theta.
So you don't do that. What you do is, let's say, let u be equal to 2 theta. So we now have u equals 26.6 degrees. And so we find all the solutions and only divide by 2 at the end.
Yeah.
And so...
Oh, so we add like 26.6 to...
Mm-hmm.
So you add it to like what tan is?
How did we do the extra tan answer for this one?
You did for that one. You did cos plus theta plus 1.
So we got 2 answers for tan. How did we get second one?
You did tan 180 plus theta.
Yeah.
So you do tan 180 plus 26.6, which is 206.6.
Okay, so U is 206.6 degrees. If we were to add 180 again, it would then be outside the range.
Yeah.
So we have 2 answers for U. We have 26.6 and 206.6.
Yeah.
So now we put it back to being 2 theta. And so...
You divide them all by 2.
Yeah.
So you get 103.3 for the one on the right. And the other one you get 13.3.
That's it. Let's see. So if you had done it the other way, you would have gotten 30. You would have done 180 plus 13.3, and so that's why it's like if it was a graph, it would have been transformed. So you'd have to do like 90 plus instead of 180 plus because it's 2 theta. But just so you can avoid all of that, just let it be equal to U. Solve fully. Go from there. Let's see. Okay, so let's try. This one is very tricky. What would be... That's A part 2. A part 1. 4 cos x minus sine 90 minus x. I'll even make it simpler than that. Sine 90 minus x is equal to cos what?
90 minus x. Oh, cos is at 3 theta.
So just this is its own question that I'm just creating. So sine 90 minus x is the same as cos what?
90 minus x.
No, x.
Okay.
They have to add up to 90. They're if sine 35 equals cos 65, it's like equals cos 90 minus. I'll have to put up more stuff. All right, so can you use that to do part A up above?
So should I work out this equation here that you wrote?
No, just
Okay.
part A up the top.
So you divide by cos.
It's not an equation.
Oh yeah.
So you have to change it into one single thing. Hold on. Right, how about 4 cos x minus sine 90 minus x.
So is x like 90?
No.
What was like 90 in front of the x?
No. What is sine 90 minus x same as?
4 cos. No, I know. Oh, it's same as cos x.
Yeah.
So you can change it to cos x.
And so, simplify.
Well, then you can just divide by cos x and wait, no, you can't. Would that just make it 0?
That's like 1 cos x.
So that makes it 3 cos x.
And so use that for this a part 2 up above.
Okay. So sine 90 minus 3 theta is cos 3 theta.
Yep.
And then you'd get 3 cos 3 theta. No, 3 cos 3 theta, right?
Yep. And B.
Theta equals 2.
Say it again, sorry?
Right. 3 cos 3 theta equals 2.
Yeah.
And then you can divide by 3 on both sides. And then you do inverse cos on both sides. This gets you 48.2 to 1 decimal place. And then you do 180 plus 48.2.
This is for cos. Do you know how you get additional answer for cos?
Is it like 90?
It is 360 minus.
Okay. So you get 311.8.
Okay, so we have 3 theta, and that's all the solutions we're going to get between 0 and 360.
Yeah. And then you divide by 3 for all the answers.
Yeah.
So you get 103.9. And you get 16.1.
16.1. Great. Let's see. Yeah, so that's a tricky one. 90 minus is the same as cos, or cos 90 minus is the same as sine.
Yeah.
Other than that, I think you're alright. They add up to 90. Alright. How about this one?
Okay. So can the cos 2x cancel out?
They'd have to have like times in between them.
Okay.
To cancel with divide.
So for this, could you times by 1 on both sides?
Okay, what do you get?
You get cos 2x plus 0.5 over minus cos 2x equals 2.
Times both sides by the denominator.
Okay, you get cos 2x plus 0.5 equals 2 minus cos 2x.
Let's do that right like that. Alright. What's next?
Multiply out the bracket.
Mm-hmm.
You get 2 minus 2 cos 4x, right?
2x. It's like if it's inside a square root, it's kind of not affected by it.
Okay. And then, yeah, cos 2x plus 0.5. Okay. And then could you... Could you divide by... Wait, but it's minus. You need to make a positive, like the cos 2x. On the right, the 2 cos 2x.
You could add it to both sides.
Okay. Yeah, and then you get cos 2x plus... Wait, no. 3 cos 2x, right?
Yeah.
Plus 0. No, plus minus 1.5. Just minus 1.5.
Why did you bring the 2 over as well?
You said plus 2 cos 2x. Oh no, wait. That adds to that. Yeah. Okay. And then that's equal to 2. Oh yeah, plus 0.5 equals 2. And then you can minus 0.5 on both sides.
Yep.
Which gives you 3 cos 2x equals 1.5. Or 3 over 2.
Yeah. Go on.
And then you divide by 3 on both sides.
Yep.
And you get a half. And then you do inverse cos on both sides.
Yeah.
For a half. Which gives you 60. And then would you do... This is cos, so would it be 360 minus 60?
Yeah.
Which gives you 300. But that's still over, isn't it?
Oh, hold on. So x is between 0 and 270.
Yeah.
What is 2x between?
Oh, it's double. So 0 and 540.
Yeah. And so that one will be fine. What is 60 plus another 360?
220. 420, sorry.
420. So that one's inside. And then this plus 360, that'll be too big. So it's actually 3 solutions. Okay, so what is x?
X is 30, 150, and 210.
And so actually, I think we forgot to extend the range in the previous ones. Let's see.
Yeah.
So between 0 and 360, but then 2 theta is between?
0 and 720.
And so this one, how do we get additional answers? We had 26.6 and 206.6.
Would you do 720 minus 103.3 or 206.6?
Once you have your principal 2 answers, you can just add or subtract 360 to them.
Okay. So you could add 360 to 26.6.
Yeah. So I think it's 386.6.
Yeah.
Any other solutions?
206.6 add 360.
That's 566.6. And try... Hang on, so if we add 360 to this one, then that'll be over. Yeah.
Yeah.
So there's actually 4 solutions. And then what would you do with these?
Divide them by 2.
Yeah, and just divide them by 2. I don't know. Yeah, I'll just write 386.6 over 2. 566.6 over 2. There we go. Let's see. All right, how about this one?
It'd be... Okay. So we got 48.2 and 311.8. And the maximum, well, it's multiplied by 3, so you times the thing by 3, so you get 0 and 360. You get 1080.
Mm-hmm.
And then you can add or subtract 360 to both of the first 2 solutions.
Mm-hmm.
So you could add 360 to both of them, so 48.2 you get 408.2.
2.
And then you do...
So I think the other one is, 6,
okay.
7, 1.8.
And then you can add 360 to both of them again.
Well done. So 768.2. What is 360 added on to the 671?
Add 6. Uh, 1031.8.
So that's just inside.
Yeah.
And then what would you do with those 4?
Divide them all by 3.
Yeah. So all those divide by 3. Okay. Yay. We're back to what we need to be. Okay. How about this one?
Okay. So for this, would you divide by, is it cos squared theta? Both sides.
Nope. So identity. Do you remember the identity connecting sine squared theta and cos squared theta?
No.
So sine squared theta plus cos squared theta is identical to 1. What is sine squared theta the same as? Make that subject.
Is it like sine squared theta minus 1?
Not sine squared.
Sine minus 1.
How do you get sine squared theta by itself?
Or you divide by sine to get rid of cos.
There's a much easier way to get rid of cos.
I just minus cos squared theta on both sides.
Yeah. So sine squared theta is the same as 1 minus cos squared theta. Okay. Can you use that?
Okay. So could you divide by cos squared theta on both sides?
Nope. Instead of sine squared theta, what could you write?
2 sine squared to 2 sine.
What did we prove sine squared theta is the same as?
Oh, 1 minus cos squared theta.
Yeah. And so now you would go about that.
Okay. So would you make sine squared theta 1 minus cos squared theta?
We already did that.
Okay. So could you add 1 to both sides?
Yeah. What type of equation do we have?
So like all cos.
Tell you what. Let cos theta be equal to a. So sublime.
A squared 2a squared theta. Just 2a squared minus a minus 1 equals 1 minus a squared.
How would you solve that?
Okay. So could you add 1 to both sides, which gives you 2 minus a squared?
What type of equation is it?
Is it quadratic?
Yep. How do you solve quadratic?
Need to make it equal to 0.
Make it equal to 0.
So you add a squared to both sides.
Yeah.
Which gives you 3a squared, right?
Yeah.
Minus, and then you minus 1 on both sides, which gives you 3a squared minus a minus 2.
That's it. What's next?
And then you can just solve it as a quadratic.
Yeah.
Okay. And you get a is either 1 or minus 2 over 3.
Okay, but we weren't asked to find a. So what do we do with that?
We substitute a back in.
Okay, for what?
So you get like cos theta equals 1 or cos theta equals minus 2 over 3. Then you do inverse cos on both sides.
Well done. Go for it.
Okay. And you get inverse cos of 1 equals 0. And then you do
inverse cos of 1.
Yeah, 0.
Oh yeah, it is 0. Yeah. Okay. Oops.
And you get minus 2 over 3. And you get 131.8 to 1 decimal place.
Okay. Can we get more answers?
Yeah, you can add 360 to both of them.
True. That'll be our third and fourth answers. Second answer for cos?
360 minus 131.8.
Yeah.
And you get 228.2.
228.2. Now technically 360 minus 0, so you could get 360 there. However, these aren't or equal to, so this 0 and 360 don't count.
Yeah.
And it's between 0 and 360. It's not 2 theta or anything, and so those are our only two answers.
Yeah.
Yeah, so it's a quadratic, and so you're getting you're getting double the number of solutions. It just happened that was a special one, and so those don't count.
Yeah.
Let me see. Not special. 0, 360. Okay. Let's see. Alright, it's a bit weird. So, part B says solve the equation. And so, if it's easier, just solve the equation and then figure out what the student did wrong.
Okay. Wait, so we're solving sine 3x equals a half?
Yeah.
Okay. So you do inverse sine on both sides?
Yep.
Okay. And you get 30 as the student wrote. Oh, it's probably because the student divided it by 3 already.
Mm-hmm.
You're supposed to divide it after you've got all the solutions.
Mm-hmm.
So you do this is sine, right? So it's 180.
Yeah.
Is it 180 plus the answer?
That's 10.
Minus the answer.
Yeah.
So one answer is 150.
Yeah.
Is that the only solution?
This is our range.
Okay. And you need to multiply it by 3.
Yeah.
And you get 1 minus 1080 and 1080.
Yeah. And let's see. So what are the solutions for these two?
You divide them by 3, so you get 10 and 50.
Okay. And so, let's see. Let's identify 2 mistakes the student made.
One is that she divided by 3 way too early.
So,
wasn't supposed to divide 30 by 3.
Yeah, divided by 3 too early. I'll just write down x equals 50 degrees,
yeah.
Not 170. So if you write down the correct answer, it really shows that you've identified the wrong answer. Second mistake they made?
They forgot to multiply minus 360 and 360 by 3.
Yeah. So many additional solutions. Yeah, I think I'd just say, minus 180. So 3x is between, so many more solutions within the range, some of that. Great. So I think it's for those ones, it's easier to do to just solve it yourself and then see where the student went wrong. Otherwise, you get confused. You start thinking, oh, it looks all right. They did 180 minus. All right. How about this?
Okay. So you can use cosine rule for this.
Yeah.
So it'd be c squared equals a squared plus b squared minus 2ab cos c.
Hold on.
And then you substitute that in, so you get c, which is 11.
Hold on. So this is just in general, but they want cos b.
So they want 7.
Right.
So 7 squared is c, because that's opposite b.
Yeah.
So that'd be c. And then a squared, which is either 6 or 11. So say 11 or 6. And then plus 11 squared.
Yeah, won't make a difference.
Minus 6 times 11 cos c.
Don't forget the 2.
Oh yeah, 2, sorry.
And it's cos b.
Oh yeah. And then you can simplify it. So you get 49 equals 36 plus... Oh, is it 121, right?
Yep.
Yeah. And then 6 times 11 is 66. And then minus 2 times 66 is minus 132.
That's it. Okay.
And then you can do 36 plus 121, which is 157. And then could you do 157 minus 132?
No. That's connected to cos.
Multiplied by, okay. And then you could minus 157 on both sides.
Yep.
Which gives you minus 108. And then you could divide by minus 132 on both sides.
Mm-hmm.
Which gives you 9 over 11.
Great. 9 over 11. Part B. So they didn't ask for B, they just wanted cos B.
Okay. So you would do inverse cos of 9 over 11.
Okay.
Which gives you 35.1. And then you do sine of that.
So do sine answer. Let's see if we get lucky.
I got 0.6.
Exactly 0.6?
No, bunch of numbers after that. So I rounded it to 1 decimal place.
Then we didn't get lucky. Let's see. So we want the sine of arc cos of 9 over 11. We didn't get lucky. So we have to do it the old-fashioned way. Let's see. Remember we had this thing earlier. Sine squared theta plus cos squared theta equals 1.
Yeah.
So sub cos into that. Sine squared b plus cos squared b equals 1.
So it'd be cos squared and then 9 over 11.
This isn't b, this is cos b.
Okay. So would it be like...
Another way to write it, it means the same thing.
Okay. So it'd be 9 cos squared. Would it be cos 9 over 11? It's 9 over 11 squared.
Cos b is 9 over 11, and so it's just 9 over 11 squared.
Okay. Equals 1. And then you work out what 9 over 11 squared is.
So that's 81 over 132.
And then you can minus that on both sides.
Yeah. What do you get?
1 minus. Uh, 17 over 44.
17 over 44. Okay.
Yeah.
What's next? We want sine b.
And you square root both sides.
What do you get?
Root 187 over 22.
187 over 22.
Yep.
However, this was sine squared, so it's plus or minus.
Yeah.
And so, is it plus or minus?
Pardon?
Is it plus or minus?
It's positive.
You're just guessing. We have to go to our cast diagram.
Okay.
This is what is plus where. So we are told, well, the cos of b, is that positive or negative?
Is that?
Cos b, is it positive or negative?
Did you use the grid to figure that out? Is it bottom right?
It is, but cos b is 9 over 11, so it's a positive number.
Okay.
There is one other quadrant where cos is positive.
Is that bottom left?
They're all positive in the all positive quadrant.
Okay.
So let's see. So which is it? Is the angle between 0 and 90, or is it between 270 and 360? Is it an acute or reflex angle?
It's on the right, so it's the reflex, right?
On the right?
Yeah, like in the grid. Oh wait, no, would it be on the left because that's cos, not sine? Sine's on the left, so it'd be acute.
So in the triangle, what type of angle is it?
Acute.
Yes, acute. And so, which quadrant?
Top.
Yeah. And so, sine b is going to be positive or negative?
Negative.
If it was in this quadrant here, only cos is positive. This angle is between 0 and 90, and so all three are positive.
Okay.
And so sine b will be just the positive.
Yeah.
Root 187 over 22. Yeah, that's a thinker. They threw us in to that one. Hang on. More teaching question before this one. See, these are all just exam questions.
Yeah.
Do like that. But you need your memory refreshed with this stuff. Alright. Okay, how about this?
So for this, would you need to use sine q? You could use cos rule. Or a sine rule, isn't it?
Yeah, sine rule.
So you have sine 45 over 5
Yeah.
equals sine q over 6.
Yeah.
Okay. Okay. So for this, do the sines cancel out?
Definitely not.
Okay.
I mean, I suppose, but you don't want to get rid of sine. You want.
Okay. times by 6.
Yep.
Okay. And then you can multiply by 5 on both sides.
Good, but we want sine q.
Oh, okay.
Calculator.
Okay. Oh yeah, you can put it all into the calculator, can't
Yeah.
you? I got x is 58.1. That's to 1 decimal place.
Did it not give you 3 root 2 over 5?
No. Wait. No. I tried to use the answer and tried to flip it, but I didn't get.
Put in sine 45. What do you get?
Okay. Root 2 over 2.
Root 2 over 2. So you have 6 root 2 over 5 times 2.
Yep. So it'd be 6 root 2 over 10.
Yep. Which is the same as?
3 root 2 over 5.
I wonder why that didn't do that automatically. Let me see. 6 sine 45. What did you put in that calculator?
Let me check. Oh, wait, I know why. Because I made it equal to sine.
Yeah,
Q.
this man. So we don't want Q. We just want sine. We want sine Q.
Yeah.
Okay. B.
So first, if you do inverse sine on the answer,
You might get lucky.
I got 58.1 degrees.
Okay.
Well, to the 1 decimal place.
So we want cos Q.
And you do cos of that.
Yeah, cos answer. What does it say?
0.5 as a bunch of numbers.
Alright, so we didn't get lucky. What can we do to get exact answer?
And you use sine squared and cos squared.
Yeah.
So it'd be sine squared theta.
Yeah.
Which is Q.
Like sine squared anything plus cos
Yeah.
squared, same thing. Okay.
And then we can just minus cos squared. Q on both sides. Or is it sine we want, right?
Let's see. We want cos squared Q.
So we minus sine squared Q on both sides.
Yeah.
So if you just did 1 minus sine squared Q equals 1 minus sine squared Q.
What is sine Q?
Oh, that's 3 root 2 over 5.
Yeah.
So it'd just be 1 minus brackets, all in brackets, 3 root 2 over 5 squared.
Yeah. And you can always use answer squared if you have it.
Yeah. And that equals to cos Q.
Yeah.
Yeah. Which gives you 7 over 25. is cos squared q, and then you square root both sides, which gives you root 7 over 5 on the right. Is cos q. And then, is that it, right? I need to know if it's positive or negative.
Yeah. How can we know?
Use the grid. So we know it's obtuse, right? And
yeah, so where's that going to be?
We know it's cos.
So where are the obtuse angles?
What, on the grid?
Yep.
It's between 90 and 180.
Uh-huh.
We also know it's cos.
Right. And so, positive or negative?
Positive.
Sine is positive. Sine was positive root 3 root 2 over 5 because sine is positive between 90 and 180.
Oh, so it's negative because c's in the bottom right.
Yeah. If it was cos or tan, it would be negative. Yeah. There we go. Got it. Yeah, so just watch out for the little negative thing at the end.
Yeah.
Other than that, not bad. This is the same process. Subbing it into sine rule, and then sub it into sine squared q plus cos squared q equals 1. Yeah, and then check the sign. Let's see. Let me see this one. It's kind of a classic one. All right, how would you do part A? Any idea how you go about part A? Can you hear me okay? I don't think I can hear you anymore.
Oh, I can hear you now.
Alright.
Can you hear me?
Yep.
Okay.
Okay, how do you do part A?
Hello?
Hey.
Alright, it's working out now, I think.
Alright.
So would you plus cos squared x on both sides?
No. So what's the main difference between these two?
We want sine.
Yep.
There's no cos.
So how do you change cos squared into sine squared?
Would we want to make it so that 3 sine squared x is on the other side of the equation?
No. How do you change cos squared into sine squared?
Was it like...
What identity connects sine squared and cos squared?
Is it 1 minus?
1 minus what?
1 minus cos squared.
So big picture, sine squared x plus cos squared x. equals
1.
Yep, that's the fundamental identity. Use it a lot. And so what is cos squared equal to?
1 minus sine squared x.
That's it. And so you can use that to eliminate cos squared from the thing.
So minus cos squared is minus 1 minus sine squared x.
That's it. So 3 sine squared x minus, instead of cos squared, 1 minus sine squared x.
Equals 2. Okay.
And simplify.
Okay. So would you multiply the minus by everything in the bracket?
Yep.
So you get minus 1 plus sine squared x.
Well done. And simplify.
Okay. So you'd get 4 sine squared x minus 1 equals 2. And then you add 1 to both sides.
Yeah.
Which gives you 4 sine squared x equals 3, which is the answer.
That's it. And how would you start part B?
Okay. You'd make, well, we already have 4 sine squared x, so you'd do divide by 4 on both sides, then do inverse sine on both sides.
Well,
You can't, it's squared, isn't it?
Yeah.
Okay. So you divide by 4, just do over 4, and then you'd square root of both sides, then do sine, inverse sine.
Yes. Hang on. So sine x. So the square root of that, I think it's root 3 over 2. However, it was squared, and so you get sine x is what else?
What would you get? 3 over 4?
Minus root 3 over 2.
Okay.
So you get plus or minus because it was squared. And
Yeah.
so you just have double the solutions. Yeah, so you do x is inverse sine of that, and then x is inverse sine of that. So just watch out for that. Let's see. Yeah, so classic thing is they'll tell you rearrange part A to make it look like something, and then they'll say this part A thing, solve it, but you'll just use the simpler of the two above. Yeah, sine squared x plus cos squared x equals 1 comes up an awful lot. You're always using it.
Yeah.
All right, how do we do this? How do we start it?
Okay. So we can make 4 sine x into 1 minus 4 sine x.
They have to be sine squared and cos squared.
So cos can be turned into sines, right?
Yeah.
So it'd be 1 minus 3 cos squared x plus 1 equals 4 sine x.
No. Sine squared x plus cos squared x equals 1. What is cos squared x?
1 minus sine squared x.
Yeah. So use that.
So it'd be 3 brackets 1 minus sine squared x.
Yeah.
Close brackets. Plus 1.
Oh, there's a plus 1.
Yeah. And then you multiply 3 by everything in the bracket.
Yeah. Squared x equals 4 sine x. What type of equation have you got?
An all sine equation.
Yep. How would you solve
Oh,
it?
a quadratic.
Yeah, a quadratic. You make it equal to 0.
Yeah.
Sine x minus 4. And you go straight to the calculator. Let's see.
Yep.
3, 4, minus 4. So we get 2/3 and minus 2.
Yeah.
But it's not x, it's sine x. Do inverse sine of -2. What do you get?
Okay. One second. Inverse sine.
Yeah, of -2.
You get a math error because it can't be negative.
It can be negative. It's outside the range. What's the maximum and minimum of a sine graph?
The maximum's 1, the minimum's -1.
Yeah, and so this one is outside the range.
Yeah.
And so with the other one, you get your two solutions.
Yeah.
Let's see. Yeah, so sine squared x plus cos squared x equals 1. Rearrange to what you need. So instead of having a mixture of cos squared and sine, you'll have sine squared and sine, which is just a quadratic. Yeah. Let's see. All right, we got all of it. Let's just go back over this stuff. Let's see. So you had to solve these. Yes. First answer for sine, cos, and tan is just arc sine, arc cos, arc tan. How do you get second solution for each?
You plus or minus for, is it tan or wait, are we doing tan?
All three. So it would be sine.
So for sine it's minus 180 minus.
Yeah.
And then tan's 1 plus 180 plus.
Yeah.
And then for cos it's plus or minus 360.
Why did I write 360? Because I'm used to doing 180 plus. Yes, you know what you're doing.
Yeah.
Those supplementary angles, I'll leave that. They add up to 3. Yeah, so sine x is equal to cos 90 minus x, or cos x is equal to sine 90 minus x.
Yeah.
Yeah, the 2 theta, 2x, 3x, you only do that at the very end. So that you can keep everything to the normal rules. But don't forget to extend the range, the domain, I think. This one sort of kind of similar. Yes, use sine squared theta plus cos squared theta equals 1 to kind of swap out stuff so that you have all cos or all sine.
Yeah.
If a student did something wrong, just do it right and then find out what the student did wrong.
Yeah.
This is tricky, but it just comes from the 3 graphs. All 3 are positive between 0 and 90. Only sine is positive between 90 and 180. Only tan positive to 270. Only cos positive 270 to 360. And so you figure out where the angle is. So this one was between 0 and 90, so they're all going to be positive. Exact value, so sub it into sine squared x plus cos squared x equals 1. This one was obtuse, and so it's between 90 and 180. So although the sine was positive, cos would be negative. And then these, was that 180 minus. And so, how was that for you, Adam?
That was good.
And so, chapter 11 next time?
Yeah.
Okay. Any questions for me in general?
No.
All right. Well done, Adam. You did great. I look forward to talking again next time.
You too. See you later.
Cheers. Take care. Bye-bye.
Bye.